mathematicians, here are your notes for 3.5, solving multi-step equations. So, obviously the goal for the day is to be able to solve them. Starting out, what action will you take when there is more than one variable term in an equation, but they're on the same side? So as you can see here, in this problem, we've got a 7x and a negative 4x. Now, we could go right to solving and trying to get x alone, but at some point we're going to hit this problem where we have an x and an x. Which one do you get alone? Well, the easiest way to avoid this problem is to simplify any like terms first. So when you say what action will you take, well, simplify like terms. And what does that look like? Well, let's use this example. 7x minus 4x, if we ignore that term in the middle, is the same thing as 3x plus 4 equals 22. These are technically the same. They're interchangeable, except this one is the simplified version. It's shorter, it's more concise, and it's easier to look at. Solving from there is the same thing we've been seeing. We're still going to deal with the number farthest away from the variable. Subtract 4 on this side, subtract 4 on that side. We're left with 3x equals 18. We've now got x times 3. If we divide, that undoes the multiplication. On this side, it becomes x equals 6. And we've got our answer. But the next problems are a little bit different. Instead of having the variables on the same side, they have them on different sides. So we've got a positive 5y over here and a positive 2y over there. If we want to isolate the variable, we're going to treat this problem the same way as we have others to this point, except we have to combine like terms either on the same side or across the equal sign. And the way we're going to do this is the same way we do with numbers. If I want to move this 2y, if I want to get this 2y off of this side, this is a positive 2y, so I'm just going to subtract 2y. But to balance it out, whatever you do to one side, you're going to do to the other. And doing this not only cancels it on this side and leaves me with just a positive 7 over here, but what it does is it combines like terms. 5y minus 2y is 3y minus 5, so that now I only have one variable term to work with. The next step is the same as all of the others. Still going to add 5 over. My pen is dying, I apologize. And then, of course, divide by 3. Notice I'm still showing all my steps. We will get to a point where we don't have to show every single step, but until we're really good and practiced with solving every kind of equation there is, be it one step, two step, or multi-step, I want to see each of those steps so that I know that you know what you're doing. Next up, we've got 7x minus 7 equals 53 minus 3x. I know there's someone out there thinking, well, can I combine the numbers first and then deal with the variables? Yeah, you actually can. So let's do that for this problem. Instead of dealing with the 7x and the negative 3x, why don't I move this negative 7 first? If I add 7 to both sides, I'm going to be left with 7x by itself on the left equals 60 minus 3x on the right side. Now that I've got these semi-isolators semi-combined, I need to be able to combine the like terms with the x's. However, some of you may want to say, well, I could subtract 7x to the other side. However, if you subtract 7x, you're going to have 0 equals 60 minus 10x, which isn't a solution because you still haven't isolated the variable. So instead of moving the 60 away or moving the 7 over, we want to get all of the x's together. So I'm going to move the 3x to be with its friend and leave this number over here by itself. Plus 3x on this side, plus 3x on this side. Now notice when I do this, because of the number that I chose to move, I've got my variable term on the left and my number or non-variable term on the right. That makes it a lot easier to solve when I divide by 10 on both sides and get x equals 6. By being really strategic and careful about what I'm moving where, I can make this process a lot easier on myself. All right, next up, what are the 4 steps to being successful when solving multi-step equations? I want you to take a minute, pause the video, go ahead and see if you can fill out that what I think column, and then come on back and we'll do it together. All right, hopefully you had time to fill that out. Now you're back, let's do it together. What I know section. So, the 4 steps to being successful when solving these multi-step equations are: 1. Eliminate parentheses. Eliminate parentheses. PEMDAS says this is where we have to start. It makes a lot of sense that that's where we're going to start. I'm actually going to go through this example as we do it. So my first step here is going to align with my first step over here. If I'm eliminating parentheses, all I'm going to change is this section. So I'm just going to leave the rest of the equation the way it is. 3x plus 4x minus 8 equals distributive property 4x plus 10. First step, eliminate parentheses, check. Second step, combine like terms with the caveat on the same sides. We can combine across the equal sign, but we're not going to do that right away. So in this case, I've got a 3x and a 4x on the left side. Those are like terms because they share the same variable and power. So I'm going to combine them to be 7x minus 8 equals 4x plus 10. My third step then is going to be combine like terms across on different sides of the equal sign. So in this case, I have a 7x on the left, I have a 4x on the right. I personally always move my variables to the left. It's just something that I've done for a long time. So in this case, if I subtract 4x from the left, subtract it from the right, balance it out, I'm going to get 3x minus 8 equals positive 10. And then notice it's combined like terms on different sides. That's not just the variable. I'm also going to do that with the numbers. So I'm going to move that 8 over to the same side. Notice this is in the same step as number 3 to be 3x equals 18. Now that we've combined like terms across and on each side of the equal sign, our final step is just to get the variable by itself. And that means using addition, subtraction, multiplication, just as we have up to this point. Number 4, to go from 3x equals 18, we're going to divide both sides, and we're left with x equals 6. If you want to put that 5th step in as check your answer, you can go ahead. I'm personally not going to in this case. All right, let's hop to the back. A little bit more drill and kill mode activated. So let's try these. First, I want you to pause the video, try them on your own, and then come back so we can work through them together. All right, hopefully you had time to try this on your own. Remembering those steps, we're going to start this first one by eliminating parentheses. 8x, distribute that negative 2 into the x and into the positive 4. So I get negative 2x minus 8 equals 16 plus 2x. Combine on the left side and the right side. Right side is fine, but left side could use a little work. We're going to get 6x minus 8, 16 plus 2x. Now we're going to combine across. Now I'm going to do this all in one step. If you can't, that's totally okay. Take it at your own pace. But what I'm going to do is I'm going to move the 2x over here, and I'm going to add the 8 over there. I'm going to do all of this in one step. When I do that, I get 4x. Notice I'm not going to touch this because the 8 is moving. So this cancels, that cancels. When the 8 moved over, it became 24. Yep. And then, of course, simplify. Divide both sides by 4. So you get x equals 6. All right, next one. Parentheses. Distribute that 4 in to get 4m minus 12. I promise that's a 12. It looks a little silly because I miswrote. Equals 8m minus 40. I'm going to do that single trick again. If you're not ready, that's okay. I'm going to move the 8 to the other side. That cancels this. And then I'm going to move that 12 to the other side. Plus 12, and that's going to cancel that. What I'm left with is negative 4m on the left and a, ooh, that's a tricky one, negative 28, I believe, on the right. Yes. Finish it up. How do we undo multiplication by negative 4? We divide both sides by negative 4, and we get m equals positive 7. If you're not okay with how fast I'm doing these steps, that is okay. Do the single steps as we've been doing in our other videos. If you're okay with going a little faster, I'm okay with you coming up to my pace too. All right, I'm gonna do a little less commentary with these. 6t plus 17, 18 minus 3. Let's see if you can keep up with this one. I'm actually gonna move that 6t to this side this time. And that means I'm going to move the 3 to that side. So we're left with 20 equals 2t. When I divide both sides by 2 to get rid of that 2, I'm going to switch it back over. T equals 10. That was really fast. That one can be a little tricky. Do it with your own method. If you have any questions, let me know. This next problem was actually supposed to be at the top of this page, so I'm going to transfer it up here, and we're going to do it up here for a little bit more room. 2c minus 10 plus 22 equals c plus 4. All right, parentheses. Combine like terms. Combine across that, so I'm going to move that negative c over. Minus 82 over here. So that would be negative 78. Divide both sides by negative 13. Oof, do that off the top of my head. That's a little tricky. Excuse me. I do believe it'll be 6, yep. Done. 2x plus 4, move the 2x over. This one I actually am going to show. These cancel, so I'm left with 4 equals 3. Now you might be really, really ready to box that answer, but if you do, I'm not going to lie, I might laugh at you a little bit, because you know in your head that 4 does not equal 3. This is not true. So what do you do when you get a problem like this, where your final answer doesn't make sense? Well, my first suggestion is always to go back and make sure you read the problem correctly. But if you get the same solution twice, and you notice that it doesn't add up, this is a pretty good indicator that there's no solution. Because there's no way that 4 equals 3, nor is there any way that we could make 4 equal 3. So my final solution there is not to box 4 equals 3, it is just to write no solution. Notice with the next one, we've got something else wonky going on. We've got 2x plus 4 equals 2x plus 4. Right off the bat, that's a true statement. And you tell me when that isn't a true statement. Again, I might laugh at you, because that's always a true statement, and we know that. But let's prove it anyway. If I subtract 2x from both sides, I get 4 equals 4. This is another true statement that is always true. However, this time, it's not that there isn't a solution, it's that because this is always true, there's infinite solutions. There's not just one solution like x equals 4 that works, or x equals 3, etc., etc. There's not just one solution. There's infinite, because any number you put into x is going to make this true. So my final answer on this problem would be infinite solutions. Let me go back and box this one. Those last two are a little tricky, but remember, most of the time you get one answer. Sometimes you get no answer, sometimes you get infinite answers. That can be a little bit hard. If you have any questions on it, don't hesitate to ask.